Hi, and welcome to the Future of Development podcast. My name's Anthony Amunategui, and I'm here to inspire people to find amazing careers in the construction development world. If you like our podcast, please make sure you hit the subscribe button down below. If you really like our podcast, make sure you hit the little bell. Zoey, welcome to the show. I'm excited about having you on. You know, anytime I get to talk about construction technology, that is my favorite thing to talk about. So welcome to the show.
Well, thank you for having us.
It's awesome. As I got into your company, I noticed you guys do a lot of different type of construction technologies. Why don't you take our audience through that a little bit?
Well, so we are a construction robotic company. We have different applications, meaning replacing some of the trade by robots. Right now, our main application is 3D concrete printing. We started this research over 5 years ago, and we did a lot of testing in our material, machine learning, the movement of the arm. And we have finished quite a few projects already. Right now, we are bringing the whole technology here in US, and we are building up the company here.
That's cool. So who's the founder of the company? Is there like one main tech person that's kind of got the genius, or is there a group of people that are doing this?
Right now, the main genius behind this is Professor Xu. He's actually dean of architecture school for Tsinghua University, which is equivalent of MIT in China, and he used to teach in a lot of American universities as well. He is still in China running the research and the design end for us. And his son Z is here with me to build a company, and we are here to run everything day-to-day basis.
That is you need both, right? You need to have kind of the person with the vision, the creator, and oftentimes they're not the ones that can do a great job of selling the product. And I talk to entrepreneurs almost every day, and one thing I notice is they get caught up in one or the other one. You're a great creator, but then when it comes to actually selling the product, it's not their forte. And it's great that you guys have kind of split the team up to have him do one and then you're doing the other part of it, which is great. So talk to me a little bit about so he got this idea. 3D printing is by far one of the coolest new things that are happening in the construction world. And let's talk a little bit about that and how you guys are approaching it.
Right now, there is two main types for 3D printing. One is the gantry system, and the one is by robotic arm. The gantry system, basically every company, they invent their own machine. And first, it costs a lot of money. And also, because a lot of them, they coming from the construction background, they coming from different backgrounds. So they are not necessarily building the most efficient machines. And our approach is we're using robotic arm. Our system is based on KUKA Robotics, which is a German company founded in late 1800, actually. And so it's a very mature system. And thinking about this as a car and an engine, so we have a very good engine. It's very flexible, very easy to maintain, very mature. And also we can use this as the research goes on. We can apply different trade with just by switching all the different tool head. That's our approach. Also by doing that, we can dramatically saving costs in few areas. First, the machine itself, our each unit costs only a fraction of like the gantry system. And also like the setting up, the transportation, the setting up time is dramatically shorter then the gantry system, also the transportation, the setting up costs is also very lower. We have done all this research, and we have the data to show.
So with the robotic arm, let's talk about that a little, because there's two kind of schools of thought, right? The gantry system seems like, okay, you go set that up, and then you have the area within the gantry that you kind of can service, right? You kind of go over an area, and and then you can raise the gantry, and it depends on how big they are. And I've seen a bunch of different kinds from folks that are doing robots that are tying rebar on a gantry system, finishing robots. There's a lot of different opportunities from the gantry to move that bot around, right? To move that that machine around, which somewhat makes sense. And then the other part with the arm. So you guys are using an arm, and typically with an arm, there's a little bit more setup, right? There's a little bit more. You need a base for that, right? And for that thing to be as perfectly, as perfect as science, it needs a pretty solid base. So let's talk a little bit about how do you set up? What's the setup for the arm in a project?
Well, actually, in our experience, the arm actually needs a less setup. So for gantry system, they have to pour in two different columns, and they set up the machines. And for us, we just so we just need to have a flat space, which will be the flat area, which will be the flooring for the house eventually. And after that, we can just place our robot with some with reels and some without reels. And we have done the testing from unpack to setting up. It's about 4 hours with 2 labor, and all we need is actually just a forklift. Some of the gantry systems, they use like crane and like more expensive and like bigger machinery, and all we need is just forklift, basically.
I think that's each group is working on different designs, right? So they're the gantry folks over there work on their design, and you guys are working on yours. And to me, I kind of honor all paths, whatever they continue to study, to learn, and I kind of feel like this is like human AI. Right, we're trying to solve a problem of mobile, being able to get more done robotically, right? As you guys look at the arm, your arm, the designs that it creates are really impressive, right? Some of the stuff that it can do. So I think it's neat to talk about that. It's just seeing. All right, so now you guys have figured out setting up. So can you imagine in the future it being able to roll over to a location, park itself, and then build a building and then roll away when it's done?
Yes, I think that's definitely will be the future. And also by not only doing the 3D printing, because 3D printing essentially only replacing the framing of the building. And with the arm movement, we think it can replace more trade, like for example, like putting on drywalls, inject insulation, painting, and hopefully when the work is done, it can it can get back on the track by itself. That's what we hope.
And then drive away, right? So, I mean, that's what you could squint your eyes today and start to see the future, right? You can almost see, a little bit of that breakthrough as we tackle one thing at a time. So right now it's got the exoskeleton of the building, right? It's got that portion of it. Later on, you put it, it drops off one attachment, picks up another attachment. It can do insulation. It drops off that one, puts another one on. It can do wiring, right? Drywall, right? You can see how that robotic arm can get. Now, how do you guys, as you start to work with that, you solve, what does it take to solve the next idea? How do you get from one to the next one? And what's the steps you're going through to make those transitions?
Well, right now we are trying to build more projects in United States as like the 3D printing part. And for our research, well, some we can see right now and some we cannot see. But for example, we are working on another robot can sanding the concrete, the concrete flat surface. That's what we work right now. We can actually talk about. But also, we also want to like replace different traits little by little. by seeing that sometimes, it might be things not necessarily like very grand, but actually make a lot of economic sense. Like for example, very small example, like cutting countertops, right? And right now for it's creating a lot of dust, a lot of like the during the process is very heavy, and a lot of times people can make mistakes, and the material itself is very expensive, and so it's need a lot of cares. Like and then if we're using robotic arm to do that, and that process is quite expensive as well. Right now, a national average is anywhere from like 900 to 4 grand just by cutting it, and that part can easily like be replaced by a robotic arm. So that's just one example. So we are not necessarily looking to do the next like grand thing, like for example building a high scraper by robot, but like little by little we want to replace the things are very repetitive, unhealthy for humans, and also make economic sense for all parties.
I think we're noticing it as we go into the robotic field, right? That makes sense, right? To knock off one thing at a time. I'm working with multiple brands that are moving over to robotics, and what I notice is that it's not as much it is inventing the machine to do the idea. The workflow has to change, right? The way that we look at the setup of a job site, the way that we look at, and some of that stuff that's made it possible with BIM technology, being able to take a digital idea and bring it into the physical world. That's really where you're seeing that momentum, right? If you kind of go along construction history forever, there was kind of last couple hundred years we're very, very stagnant in development. BIM comes along, and now all of a sudden you're seeing the curve move up, quite rapidly. And being able to see that, what has to change also though is the workflow stuff that we're doing, right? There's still a lot of the cowboy mentality on job sites, right? Being able to go to robotic, we need a lot more precision, right? And in order to get precision, we have to really develop the front side of a project a lot clearer, so that that robot shows up in a spot that it can execute on. It's got the space is regulated in a way that makes it very static, and robots need a pretty precision site to work on. So I think a lot of that transition you're going through is as much on the materials on the equipment side, it's also on the workflow side.
Yes, I agree with you 100%. One of the big issue in construction is, from design to engineering to build it, is a lot of information loss, a lot of like a lot of information loss, time and money. But by digitalizing everything can streamline the process. And also the reason why we are doing all this research, for example, just the concrete printing, we actually spent over 180,000 hours into our material research. That's why like we can print like things like sculptures and overhanging designs. So the reason why we spend so much time and energy in our research is we want to do the hard work in our lab. So people on site only need to get it done fairly easily. So for the labor, for our laborers, and we can just find them, through like Craigslist and a very entry level labor job. Even the Wujiazhuang farmhouse we print, we actually hire local villagers. So they are not necessarily like skilled labor. So like they don't really necessarily need to have like be a very like strong male to operate the machine. So we want to do all the hard work in the lab, so like people on the job site can have a fairly easy work.
Well, I think that's exactly right. I mean, now, if we can transition over to robotic support, right? And I think that's the thing that that's exciting. I think sometimes when you say robots, people think of Terminator, right? They imagine the little finger. Remember in Terminator, there was that finger that attacked you. Like it was like the world's going to end, robots are going to take over, and somehow or another, there's a little bit, just a group of people out there who are so afraid of this evolution to robots, and maybe right, and so that if we don't do this properly, the future may have issues. But as we start to walk down that path, the things that robots really are going to be good at are the things that are terrible for us, right? The jobs that are repetitive and dangerous, the ones that are static in idea. And I think that what happens is today our labor pool is so limited, right? Where every person I know on just about every job site needs more people. And
Yeah.
when robots can come into play and start to support you differently, like you said, I think you can spread out your labor pool much differently. Now it could be villagers, or it could be where it was a big burly man, it might be a younger person or an older person, and they don't need as much physical conditioning as they did when in our early days, when we carried heavy stuff and needed big strong men to do that.
Yeah. Well, yeah. Also, well, skilled labor is we have a big shortage in skilled labor. Like even for small stuff, like just for example, cutting stones. If you don't know that well, you may injure yourself, and it's required. It's very heavy. Have a lot of heavy lifting, and also like the precision, how you design, how you cut it. But all this movement is easily to be replaced by robot. But we are not really replacing the jobs. We just we just provide better tools. Essentially, that's what it is.
Yeah, I think sometimes we want to tiptoe around like, oh my God, we're going to replace humans, and people are afraid to have that conversation. I'm like, look, if a robot is taking over your job, you had a crappy job. Yeah, I mean, your job was probably dangerous and repetitive, right? I mean, if a robot took over your job, now as you start to get out of that crappy job, and now you can look up and go, all right, now I've got someone else is doing the repetitive, dangerous, heavy job. Now I can do a more technical job. I can go back, and the people who did that job before are the best candidates to support the robot, right? It always seems to me that as we go into robotics and we do that conversion, or we go to automation of any kind on a job site, the people that did the physical work seem to be the best adapted to understanding how to set up and start to operate the automated system.
Yeah, and also like for example, like when they're manhandling the materials, and if they can just manage two robots to work at the same time, and you can, actually have a better income as well. A lot of time in construction, like all this job, they are very like it's kind of it's very repetitive. It's very I don't want to say, but sometimes it can be dead end. But if we deploy more robot and better tools, the construction efficiency can come up, and it's actually will be more profitable for everybody.
Yeah, I think if you look across our society, right? If you go back to my grandfather's, my great grandfather, he was a carpenter, right? And if you wanted to work with my great grandfather, you would have to go to my great grandmother's house, and because he'd be on a job site somewhere working, and you'd have to go over to her house, and you'd have to sit down for 3 hours, and she'd have to have coffee with her and tea, and you'd have to you'd have to get her to like you so that she would tell my grandfather, right? And then my grandfather, if she told him, he would then go over your house somewhere in the future, and then they would do one project at a time, and it was very labor intensive, very slow communication. And as we continue to automate, right, as we start to go automation, right, what ends up happening is, if you look around today, I don't know that our lives are any easier, right? I don't know that.
Exactly.
I don't know that really. I think they're faster, right? We're going a lot faster, but we're all doing a lot more. We're actually getting a lot more done. My grandfather's time, my great grandfather's time, he worked on one project at a time. Go ahead and you tell me you work on one project a day. No way, right? We're all doing 2 and 3 and 4 things at a time, while managing families and businesses and cell phones and all the things that we manage on a given day. I don't know that life gets easier, but now we can do more, which ultimately, if you look around, I'm seeing society kind of doing a much better job, right? You're noticing, all right, people are living pretty darn good. Now we're eating pretty regularly. We're having, society is starting to do well, as long as we don't go kill each other with some stupid wars or something, but or a pandemic. We're all doing, the society, we're growing at a pretty steady pace, and technology is helping that process, right? Not just the software technology, but the physical technology. Things like robots are helping out pretty well.
Yeah, I definitely agree.
So
Yeah.
so let me go back. You hit on a couple of things I rolled over pretty quickly, but so material sciences are, to me, are one of the neat big frontiers, right? I'm noticing that as we, brands like you guys that are out there inventing multiple construction technologies, the material technologies are a big part of that, right? In order to get materials that work in 3D printing, that's a big one right there. What are some of the works that you're doing that are, working through the material sciences?
Um, well, so our research hours are actually mostly in materials, because 3D printing concrete is actually a 4D material. We have to achieve the strength within a certain time, and it cannot be too fast or too slow. It has to have a certain consistency when it roll out of the printing nozzle. On top of that, because we want to print things with more design, we want to have more ability to do the overhang. So it has to have the right strength, and a lot of time, like some other 3D printing companies, they what they don't tell you is each layer they have to wait about like 10 minutes so they can print another layer, and that's actually a lot of time will be in the waiting. But for us, we can just print one layer on top of another consistently. So that's one thing. And a lot of people was very concerned about the carbon footprint because we're actually using concrete. But the truth is, because we don't need the framework, so just by that, we don't need to build up we save a lot of lumber, and that's also associated with money and the time. And also because with 3D print and we using the BIM modeling system, so we analyze the model, we can minimize the usage of the concrete, which is another big cut from the traditional method. On top of that, we will keep we are keep doing research in other materials like handcrete and all these kind of things. So yeah, so I would like to say, like as a technology evolve, we can actually build better building more efficiently and more eco-friendly as well.
I think that's neat. As your material sciences continue to evolve, and sometimes it feels like you're on the bleeding edge, not just a leading edge, you're on the bleeding edge, right? You're going through and discovering all these new ideas, right? So you figure out, all right, here's a 3D printing arm. You get the arm to work. Now you start working on the materials, right? Here's how I get the materials to work and actually make it so that I can print faster, right? How fast can you can see a time in the future where that arm is going 50 times faster than it does today, right? As material sciences get smarter, and I looked at my doctor's office, my dentist's office. I used to go to my dentist's office, and they would put a tooth in, and the drying time for the material was forever. Now they got some sort of light they use, and it hardens it instantly. I'm like, it's amazing some of the stuff that's happening in material sciences across the world, and as we continue to break through that next level of idea, I go, great. Now I've got these materials or these hardeners or this stuff the material that we used to build a building. I had a podcast with a group that had a material that they were using that's self-healing, right? It's got like a bacteria that they put into it, and as a wall cracks, it any airflow that goes inside there causes the material to self-heal itself. And I think that's kind of fun as we keep learning, and groups like you that are on that front edge of that that's exciting. I mean, that's where, the young people in the business, a lot of people didn't want to go into construction.
Yeah.
But what I'm noticing is that today, because of companies like you, that you guys are out there inventing new ideas, right? Why do people love Elon Musk? He's out there he's being bold, right? You guys are being bold. You're out there on the bold edge of the world. And I think that's a pretty neat spot to be. It's inspiring, right? I think people want to be a part of that vision, that goal, right? To really recognize that you guys are a leader in bold thinking.
Yeah, well, that's a great comment. Thank you so much. Construction is a big industry. We definitely want to see more people involved and more ideas brought in. Like for example, as you mentioned, like how fast we can print. We can print 2 meters per second, but like sometimes on construction site, if we finish printing the framework for like 3 days, or if we finish in 2 days, doesn't make any more difference, because like all the other trades has to come in, like the plumbing, electrical, like flooring, all these other trade has to come in. So only if all the other trades begin to like more like people can put them up more efficient, the whole productivity can really increase. So it's a lot of different angles in this whole industry people can work on. We definitely want to see more innovative people coming in.
Well, I think this is just natural, right? That's a natural part of the progression. So you guys figured out 3D printing of the shell, right?
Yeah.
And you go, well, great. Just because I can go faster, great. But now the problem is it's not doing much good if the rest of you guys can't catch up and aggregate this opportunity, right? If you guys can't add on to this and really make this whole thing, the collectives of this, a much faster process, what good am I going to do, right? It does not make sense for the building for me to run, get this done, and then it sits there for 3 or 4 or 5 days to get that finished. So I think that's some stuff that we're going to notice, and it now creates opportunity. Okay, great. You guys are printing 3D buildings. I keep asking folks, why are our electrical and our plumbing hookups not becoming that same way? Why aren't they harness, right? If it's a BIM model, we know
Yeah.
we know the product really well, just like the automotive business. They don't have a guy inside of their wiring a car up. It's a harness. It's a pre-wired, pre-engineered, precise belt of wires that gets laid right into the car and pulled right through, and it matches up perfectly. Here's where the headlights, and here's where the taillights, and here's where right. It doesn't. There's not some guy or some human inside the vehicle trying to wire the car up. It's a harness. And now that we've got BIM technology, you guys have, well, first of all, that now inspires the next group, right? When does a great electrical group come out and go, hey, great, we've got the electrical harness that goes right along with that model right there. And because we have technology, we can see it. And what's great about that is we can now in a laboratory, you all rate that. Right now it becomes a much safer product than ever before, right?
Yeah. It should be a prefab of like a hybrid between on-site and off-site construction. A lot of people only want to solve the problem, including Elon Musk, only want to solve it with a prefab way. But sometimes prefab isn't necessarily good. Right now the cost is still very high, and also it's good for very repetitive buildings. Like for example, like some of the hotels, apartment building, but a lot of times, human have different needs, and a lot of like even for residential homes, people want different designs, configurations. They have personal preference. I don't think prefab can solve all the problems. So I think on-site and off-site, more automated construction will be will be the future. That's what I think.
No, I mean, for sure. Material sciences will now give you that ability to do that. As you're designing a building and you look at it and go, well, here, I'll use these harnesses and these lights and these fixtures, but we'll 3D print the building on site, right? On site, we'll have a perfectly designed 3D print, and these are the parts and components that we're going to put into that. And I think that, that's the stuff that we can't see that yet. I think the problem is that we are most of the business is still stuck in its old ways of seeing things. It's these 2x4s and 4x8s, sheets of plywood. It sees things from the past, right? And then you start saying, well, you guys come along and you start inspiring people. Oh, look, we can 3D print right on site.
Yeah.
Now that gets pretty, pretty sexy. Right now, all of a sudden, you've got this new idea, and oh, maybe I could do that. Maybe I could have a 3D printed house. I could customize my house to be exactly like I want it to be. And because I'm now doing it in BIM, I can see the structural components. Before the structural components were so rigid because you had people went to the same toolbox every time. You
Yeah.
you go in there, you go 4x8. Here's a 2x4. Here's what
Yeah.
the structural component of a 2x4 does, and then the kind of structural engineer knows to do that. But as we start to do it in BIM and we can start to model these things much differently, I can start doing understand my structural components, in that BIM model, way different than I ever did before, which will give me so much more flexibility in design.
Well, construction industry is such a big industry. It's changed slowly, and it's actually not a bad thing, because we are building things will last for at least like another 100 years. And to when you have the new ideas and we have we build it out slowly and with conscious, it's actually, in my mind, it's actually a good thing. So we want to and also each project sometimes we'll take some time to execute as well, but eventually when it makes economic sense and more things will be changed. I think that will be one of the driving factors as well.
Yeah, I mean, look, for hundreds of years, maybe even thousands of years, we've built almost the same. I think the biggest change we've had is the cordless screw gun, right? Maybe some cranes and some big equipment, but pretty much what we're doing in the construction world becomes very much the same. It hasn't changed much, like you said. People are creatures of habit, but as you guys start doing. You start looking at one robotic arm, then you start looking at job sites with 2 robotic arms. You can imagine job sites with 10 robotic arms, all working simultaneously to build all kinds of unique and amazing structures, together. That future of this game becomes really, really neat, right? You start imagining, them rolling into a job site today. What you're using. I hate to use it because the production crew over here, you guys are gonna bust my chops. They bust my chops all the time about, this is the bag phone. I don't know if you ever had a bag phone. When cell phones first came out, they came with this big giant bag, right? And you had to carry it around, and it was, you had to put it on your table, you had to carry it in your car, and it communicated to the tower, and it was really expensive. A lot like we're doing right now. The robotic arms today they're heavy, they're arduous to work with, but we're just trying to solve the problem, right? Trying to figure out how they work, the material sciences, not just that, the software that it takes to do it, right? How to integrate the software and the BIM model together. So as you're solving all of these problems uniquely and excitingly, right? Now they get smaller, they get lighter, they get faster. All of a sudden you get 10 robots or more working on a job site much faster, right? You get 10 of these arms going and they start printing much faster, right? And it's drying faster, it's hardening faster with different techniques. Those answers start happening, and all of a sudden you start looking at, oh wow, the price will drop, right? The opportunities, right? If you look at our phones today, they're better looking than ever before, right? They're neat, and they're getting even crazier. Where they're going in the future. I was just in Dubai looking at new technology out there, and I was like, wow, the stuff that the innovation that's coming in the communication world, gets even better. So I think that's the thing. It's hard to see from here where we're going, but you guys are doing an amazing job of starting, and not even starting. Actually, now you're a few steps into it. And let's talk about, you guys have multiple robots, right? You have multiple bots that you're using. Let's talk a little bit about those.
We have 3 types. we have the rig 0, which is a fixed robot, and it can and also we have the rig 1, which is the robot on the rail, and we have rig 2, which is the robotic arm on a scissor lift platform and with 2 rails. So our system is pretty modular. That's why we can bring very small product to very big, as small as you want and as big as you want. And even the project with like the parking in Shenzhen, we actually deployed 4 robots, and that's a park over 55,000 square feet. And that's a park over 55,000 square feet, and we printed over 2,000 objects from design to finished construction. We managed to do that within 2 months, and the cost is relatively low compared to traditional method, because like the sculpture by itself can cost a fortune to make, and sometimes it may never come out the way they designed.
That's that's a big part of those transitions, right? You're starting to get design. I've seen your bridges that you've done. I mean, the park, all the stuff that you guys are doing. You continue to those are the frontiers, right? They're like little battlefronts that you're working on that you keep passing through the next battlefront. Right? You're learning, you're trying out new spots. Everybody in the team gets to try on innovative ideas, from the design team to the actual execution team. Everybody's getting to do a touch of that, and I hate to say it again, but it inspires me, right? It inspires me to do big ideas with it, right? I start looking and go, all right, what can we build that will be unique? Unique. Can you use this arm to adapt older buildings? How can you site adapt, existing spots in the world? Continue to look at that. So the 3 different arms you have, you got the arm itself, then you got the gantry system. Right, so the robotic arm that's on the robotic arm, and then you have the robotic arm that's on the
scissor lift platform.
Scissor lift platform. So that's an arm on there.
Yes, also arm on there, with the 2 rails. That's so we can print taller structures.
Neat. And what are some of the other stuff that's on the front? I heard you sneak out a little bit about your floor polishing machines.
Yes, we are working on that right now. I want
the inside scoop. Give me the inside scoop. Tell me about what you're doing.
No, I will let you know when we have something more to show. You will be the first one to know.
Awesome. You got to make sure you bring it out here, because look, we love new stuff. We love it. It's fun when we watch groups like you guys continue to break through these fronts. The robotic arm is for sure neat, and as you guys get better and better and better at it, look, I'd love to go to when you do a live broadcast from one of your projects. So as they're coming up, and your group does, look, I like to go out to your R&D lab. I love going to R&D lab. So if you got a chance to bring me out to your founder, I'll go out there and do a live broadcast from there. And it's exciting to watch you guys, the way that you're thinking, the innovation that you're putting out there. You're on the leading edge of it. Zoey, it's fun. My conversations with you have been really interesting. I want to continue to watch you advance in the world. And if I can shed light on the work you're doing, please make sure you bring it back to the show. We'll be excited to continue to do that.
Well, thank you so much. And we will love to having you in our lab and also on our job site. Thank you so much for your time. And this is really fun.
Well, awesome. Make sure that, hey guys, if you guys like the podcast, please take a second right now. Just please, for me right now, I'd like to like and subscribe for me. And if you could share this with your friends, that's the only way we know that we're doing okay. If you got some other people you want us to talk to, or somebody you want to ask, or a question you have for us, please take a second and put that down in the comments right now. If you could like and subscribe, it makes all the world of difference to me and the people that come on the show. So thanks for being on the show today, Zoey Zhao. I'm grateful for the work that you guys are doing, and look forward to you coming back on here and showing off more of the cool innovations that you're putting out there.
Well, thank you so much.
Thanks for joining us. My name is Anthony Amunategui, always looking for people to bring insight into the industry, finding ways to inspire people to have amazing careers in the development world. If you liked our podcast, make sure you hit the subscribe button down below. If you really liked our podcast, make sure you hit the little bell. Thanks again for listening. Please share it with your friends.